Hello, today we're going to show how easy it can be to take MATLAB functions and deploy them to industrial-proven hardware with real-time execution within our TwinCAT real-time. In our demo today, we will use TE1401A target for MATLAB to take a series of MATLAB functions and deploy them to a TwinCAT real-time as a PLC library and standalone executables. Let's get started. Here, we have an Xts Transport Application. The XTS is run by an XTS Manager class implemented in structured text. The class has a method to check the dynamics set by an operator. It currently only checks the max and minimum values, and we need to extend this to account the restrictions on the dynamics caused by the load. We would do this with MATLAB functions. In MATLAB, you can create Matlab function files and then populate them with your code. Here, our function takes 3 inputs and returns a force value for the given load. This function calculates the current system current for a given force. We take our defined functions and specify a library name for this set. These functions are then passed into the MATLAB coder, which gives us a C++ compiled output. Before this, they are parsed into a typing script to allow the coder to determine the type to the function's inputs and outputs. You can see the force, the current function here. Following on from MATLAB coder, we use TE1401 target for MATLAB. In a similar way to the coder, we set up the build options such as targets OS and code export. We can also provide version libraries, allowing for continuous development of the function set in MATLAB. Finally, we set the options to produce a library and install directly into TwinCAT for use in our PLC projects. The TE1401 target for MATLAB supports all the functions supported by the MATLAB coder, including things such as parallel computing with par4 loop. This process can also be automated using TwinCAT's automation interface, which allows you to script the build and deployment of the TwinCAT project, meaning you can create a MATLAB script to build and integrate a library in TwinCAT before deploying it to a TwinCAT target, or directly from MATLAB itself. This allows the easy integration of continuous integration, continuous dependent pipelines, and source control tools like Git. Once the build and publish process is finished, we will have an installed library ready to use in TwinCAT. Switching back to TwinCAT, we install this library under the References node in the PLC projects. And we can also select previous versions of the same library. Opening the library allows use to see the function blocks created from our MATLAB functions, as well as inspect the interface for each. Returning to our class, we create an instance of the check force function and call it in our method. We pass it in user-defined acceleration and known values, in this case for the center of force and the moment inertia of the load. Finally, we check that the force calculated from the acceleration is less than a limit. In this case, we'll use the continuous force for XTS mover, which is 30 newtons. If we are below this, then we can set the acceleration in the system. In the main, we make a call to the method of the XTS class. Typically, you would do this as part of a sequence or a HMI event. Logging into the PLC, we can then test the function by simply supplying accelerations and ensuring that anything over 30 newtons is rejected. Here, we pass in a value of 15 meters per second squared and see the corresponding force calculated by the function. Next, we will try it for 19 meters per second and notice the force is over 30 and therefore the acceleration is not written. Next, we will look at the functions implemented as standalone executable objects in TwinCAT. Opening the TC-COM object browser, we can select the functions individually and add them to the project. The functions inputs and outputs then form the TC-COM process image. Unlike the PLC, they need a separate task to run. Add a task and set in the context of the TC-COM object. Once done, we can activate the system and make use of the function. When running, we can use the process image to test the block. Setting values for Imax and Fmax gives us our current force conversion. And we can then supply values in for friction that are then converted to an equivalent current to overcome that friction. We could have cross-linked the process image directly to I/O and therefore link Matlab functions directly to any field bus. We can view the Matlab code through the code view in the block diagram, and we can also reparameterize through the same interface. As a helpful tool, we can extract the scope signals and allow us to monitor what is happening inside the system and observe any changes. You'll notice that this module is not for commercial use because this is a free trial version available for use by anyone for testing purposes. Thank you for joining us, and for more information, please visit us at www.beckhoff.com.